Live. Let's see what happens today. All right. For those of you who are very astute, you might notice that this is a little bit of a different setup than usual. Which is fine. But yeah. I never really got confirmation on whether or not like this is a good format or not for people. So I'm gonna keep using it just because like all the links I have right now are all to this site at this time. So I think like when we come back from spring break, maybe we'll shift things around a little bit. I know some of you were in a Zoom meeting already today, which is cool. It doesn't look like there's anyone in here just yet. So I will hold off on saying anything significant until I get a few of you in here. Oh, interesting. The topics of the day is cut off a little bit. Just making some notes for myself. Trying something a little new to see if I can follow what's going on in the chat and like who's around and all of that. Okay. All right. So don't think I'm totally alone anymore, but maybe I am. Okay. All right. Some people are here. Good. How's everybody doing today? Feeling good? Feeling all right? So if you've watched the videos that I uploaded this afternoon, I meant to upload those videos this morning, but I had a disaster of a time figuring out the editing I needed to do to like cut the videos up and edit out the parts that were just like me futzing around getting it started and ended. So like I'm not doing intense editing, but the editing I'm doing is like takes raw time. And it took me way longer this morning than I thought it was going to be. So that's why those videos didn't go up until later. Oh, people checking in and then checking out. Interesting, interesting. I wonder why. I wonder what people are expecting to happen when they log into this. I may never, ever know. Okay. That will help me follow the chat a little bit better. Good. Okay. So yeah. Still no one here. So a couple teachers have, well, I'm not really talking to anyone, whatever. A couple teachers have talked about using platforms like this or like Zoom Hangouts or Zoom or Hangouts to treat them kind of like in college we would treat what are called office hours. So if you know what those are, that's kind of what this is now. If you don't know what an office hours are essentially like the lessons have already happened, right? You've watched the videos, I'm leaning back too much. You've watched the videos, you've thought about the material, but um, what this is now is not like mandatory learning experiences. This is essentially your chance to check in and ask new questions, follow-up questions at kind of like your own pace. So I was saying like this is some teachers have put together office hours or like digital classroom hangout time. That's kind of, I think, what this might turn into. So I'm not necessarily going to do anything new during this time. Um, but this is your time to like check in, ask questions that you feel like didn't get answered in the videos that you watched earlier today, or follow-up questions on the Desmos activity about things that like were confusing or you were stuck on, and all of that. So partially the reason I'm thinking about it doing that way is that's kind of more what other teachers are doing, and it might be more familiar if kind of what I do is more similar to what you're doing for your biology class or what you're doing for your ethnic studies class. Part of it is because in general, like people who show up here either like show up and then tune out almost immediately, um, or they show up and they kind of asked very specific questions about material they're feeling stuck or confused about. So it's kind of already office hours. The one thing that I was thinking would be important is that I have some kind of purpose when I log in each day and start streaming each day, that there's something I know I'm going to go over. Partially one, so I'm not just bored and like twiddling my thumbs waiting for you guys to like ask me a question. Um, but also so like there's some structure to this hour beyond like, hey, good to see you, you know. Um, that's also a product of the format because this is a little bit more one-sided, right? You can ask questions, I can answer your questions, and I honestly love doing that. Like that's what I hope to do more of. But it's not as simple as like it would be if you could talk to me directly, or even if you could talk to each other, right? All of that would make things go a little better. So I haven't figured out a Zoom thing. I probably, if I do a Zoom, it'll probably be tomorrow, and I'll send out the link either later tonight or tomorrow morning, and we'll do a Zoom type of meeting. Like I said, you might have already done that with another teacher, either today or earlier this week. And so I might do something like that for math as well. If I do that, I'll probably have at least some plan of what to talk about. Like I'm going to talk about some math problem. Um, Even if it's just, hey, let's all log into Desmos and like do the Zoom activity together, or do the Desmos activity together while we're all on Hangouts or something like that. Yeah, yeah. Have you done one already? Have you Zoomed with another teacher yet? Is that something that's happened? I know some teachers have done it, but I'm curious which students are participating in that. Mm-hmm. Was it fun? Was it good? Did you enjoy yourself? Short? Yeah, yeah. I feel like if I was in the call, I would feel really like awkward about leaving early. but I don't know if that's like just an etiquette thing that because I'm older, I feel that way, or if it's like, oh no, pop into the Zoom call, pop out of the Zoom call, like whatever, you know. Versus like streaming, I kind of expect people to like pop in, and then if this isn't like helpful to you, you know, you probably won't stay for too long. I get that. Yeah. Okay, so the plan for today is to go over one question, maybe two questions that didn't get explicitly answered in the lesson, which was by design. The videos were getting long, and two, I want there to be something that's not just like a cliffhanger, like, hey, you have to tune back in, but like something that kind of forces you to see if you can figure it out on your own. Where even if you just like don't pause and keep watching, there are still things that are like, well, for you to figure this out, you're gonna have to like really think about what's going on here. So the question that we didn't answer was this one right here. What happens when you graph these points? And by these points, I mean these are the points in the table that we made at the beginning of this activity. So this activity is based on the dots you see to your, where am I going? To your left, right? To your right. Did I get it right? Yeah, okay. To your right. And if you've done this activity, great. You've already done some annotating. You've already analyzed some of these points. Hopefully you've already created a formula. And so now what we want to do is we want to graph that formula. If you have the benefit of a printer, you can print out this assignment and graph the points directly onto this graph, which would be great. If you do not have a printer, then you kind of have to do it on lined paper. And if you don't have grid paper, then doing this is really hard to do precisely, which is kind of the whole point of graphing to begin with. So what I want to remind you of is that you don't have to graph this by hand if you don't want to. You have technology, and you can go over to Desmos and to the grapher on Desmos and copy the tables into Desmos and graph it there, which is what we're going to do right now. So I already have Desmos open, and we are going to start by making a table, T-A-B-L-E, and it immediately creates a table for us. So the X values we're going to use are going to be the step numbers, 0, 1, 2, 3, 4, 5. And for this activity, it jumped to 10. So those are the step numbers. For the green dots, we'll use pattern number 1. So pattern number 1, I'm looking here, pattern number 1 had 1 dot, and then 3 dots, and then 5 dots, and then 7, 9, 11, and then we figured out it jumped to 21. So those are the dots for the green. And then I'm going to do the same thing, but for pattern number 2. So T-A-B-L-E, and this will be blue. So again, the X values, the X values are going to be the step numbers here. So X value is 0, 1, 2, 3, 4, 5. But the next one we're going to do is not 6 because it jumps to 10. And those are X values. Then we go to the Y values, which are 0, 1, 4, 9, 16, 25, 100. Okay, now that I have those tables in place, I'm going to full screen the Desmos activity so that we can compare the images. So first, let's just look at the green dots. So I got rid of the blue dots and we're just looking at the green dots. And what do you notice? When you look at the green dots, What kind of shape do the green dots seem to make? Remember, we graphed 1, 2, 3, 4, 5, and then we jumped to 10. So that's why there's that big gap in the middle. What do we see? What does it look like? Let's see if anyone from chat will answer. Give everyone a minute to think. Oh, it's really dark. Every time I drink my tea, does the colors short out? Yeah, the color kind of freaks out every time I drink tea. Okay, so it doesn't look like anyone from chat's gonna jump in on this one. But hopefully you guys see that like it looks linear, right? The dots look like they're going along in a straight line. Using my mouse cursor, like, do you guys see that right here? Like, straight line, right? Okay, contrast that with the second pattern. What about those ones? Do those ones look linear? No, they do not. They look a little bit more curved. Also, it's worth noting you can't see the last dot because we're not zoomed out enough. The y-axis only goes to 30 here. But remember, the last y value is at 100. So if we wanted to see that, I would need to change the scale of the Desmos graph, which I can do by clicking on the graph settings button here. So if I click on graph settings, I can, on the y-axis, I can make the top y value here, I can make it say 120. And if I do that, oops, that's even more, then I can see that 10th dot, which is way, 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 way higher than everything else. So this does not look like a line. These points are not connected in a line. And the question is, well, what kind of shape are they connected in? And since we have done some extra work before this lesson last week, looking at a couple different shapes, that's not hopefully like a mystery to you guys, right? We've already done this work. We've already named the shape that we're going to be studying. So maybe a better question is, do these points look like a parabola to you? Knowing that a lot of things are missing, do these points look like points along that U shape that you have been looking at before when you're thinking about the basketball, when you're thinking about the football video, when you were doing the parabola gates activity, right? Do these shapes, can you mentally connect the dots in your mind to create that same kind of parabola shape? Hey, how's it going? I see you there. Thanks for joining. Thanks for tuning in. Were you just trying to get my attention, or were you just saying hi? Either way, good to see you. Glad to hear from you. I'm glad you could stop in. So I'm gonna half screen this again so we can go and like answer this question here, right? What happens? Both good. If it's easy to do, type in any questions you have in the chat and I will do my best to answer them. Sometimes typing in math is hard, but do your best and I'll get creative about it. So the question is, what happens when we graph these points? And we say, well, the linear one looks like a line, and the other one, the quadratic one, looks like a parabola. In what is 2 plus 2? In one of the show me's, the show offs where people are like, oh, here's something I think is mathematically interesting. The number of people who wrote 2 plus 2 is higher than you might expect. Why 2 plus 2? Why not 1 plus 1? Or 3 plus 3? Or 5 plus 8? Like, I don't know. There's some psychology there. There's some psychology there about why 2 plus 2. The answer is 4, by the way. Unless you're doing something tricky that I don't know about, which is possible. I'm looking over here because this is where I see my chat window. I'm not just like randomly ignoring the main screen. Yeah. All right, so that's the answer to this question, right? Lines look like lines. Lines look like lines, and then the quadratics. This one at least seemed to look like a parabola. Let's see. Okay, so there's this last question here that says exponential versus quadratic. And I think like since we have the power of Desmos, I think it might be worth it to like actually just show you guys some Desmos things. Just so you get a chance to like see what they mean when they ask you to compare these things. So like, here we go. So if we want to make a line, y equals 2x plus 1. Here's a line. Ta-da! And then if we want to make a parabola, here's a parabola. And if we want to make something exponential, we can do something like this. And so the question is like, what's different and what's similar about these? Exponentials are like particularly, let's do something a little less extreme, just so we can look at it. Exponentials are particularly interesting in this time of your life because of all the information we've had about the spread of the COVID virus, right? Like these shapes are showing up in the news every single day. And it's not because someone is plugging a formula into Desmos. It is literally because the exponential formulas model how diseases spread, right? You could ask like, which comes first, the math or the truth? And the answer is like, well, they both kind of show up. But in our life, we look at the data and we say, oh, that data looks like something we can model using mathematics. Now, what we hope is that at some point, the trend stops going up and we can do something artificial to cut it off, right? The math says if we do nothing, everyone's going to get sick super, super fast. So when we're doing these social distancing techniques, it's us trying to avoid what the math says is going to happen, right? If the social distancing works, the actual data of the graph will look different than just the basic exponential graph. Like that's the dream, that's the goal. Sorry, that was just an important notice about exponentials. So that's our exponential curve. This is a quadratic curve. And if you want to just look at half of it, we can just restrict it to look at half. This right here says only look at the x values that are greater than 0. So it only starts at 0 here. And the quadratic kind of looks like the exponential, right? Like the exponential curves up, the quadratic curves up. Arguably, one of the big differences is that the full quadratic curves up on the other side as well. Like it's like a U shape where the exponential isn't. And when someone's like, well, what is the quadratic model? You actually already know the answers to those questions, right? This shape has already shown up in some of our videos of the day, looking at a couple different things, but most notably the football, when you throw a football. It's shown up on Desmos, when we throw a basketball. And it's shown up in our lesson when we're looking at how to calculate the area of a rectangle. And I'm going to tell you right now, it's also going to show up again in tomorrow's Desmos activity as well, which is a bit more interactive and fun. So if yesterday's Desmos activity was hard, don't worry. Tomorrow's will be a little bit more, I don't want to say easy or hard, but a little bit more user-friendly. Let's say user-friendly. Yeah. So in some sense, like if you're a math teacher and you're looking at this, you're like, aha, yes, this is Algebra 1. You spend however much time learning or relearning about graphing lines. You spend a little bit of time learning about graphing exponential functions. And then we're basically going to spend the rest of the year studying how to make more and more and more complex and interesting quadratics or parabolas. So like this thing right here, we're going to get to know it real well. So that's it. That's it. This in a nutshell, if someone's like, hey, what do you study in algebra? Boom, boom, boom. We study lines, we study exponentials, we study quadratics. Not necessarily in that order. But yeah. All right, that was it. The only other thing on my list of to-do items for today is to go over some DeltaMath activities if you want. But I'm still waiting for this last question. I've kind of been vamping because I'm hoping to hear it. But I haven't forgotten it. But my plan is to use the stream to go over the Wednesday homework, or the Wednesday DeltaMath, answering questions along the way for anyone who has questions. No last question? You're just going to dip? All right, fair enough. Fair enough. Okay, so let's do some Wednesday DeltaMath assignments. All right, so this is going to be a review for the types of problems of Wednesday's DeltaMath assignment. Let's get right into it. All right, so already we see that we've got this table and we've got 4 different options: exponential, linear, quadratic, or not a function. So what we're going to have to do is we're going to have to make sure we look at one of each example so we know how to find which one is which. So here we've got, and to do this, I'm going to be doing a little bit of math in my head so I know which example it's going to be, but I'll go over the ones that we all go over. So here we've got, what do we need? We need to find a linear example. We need to find an exponential example. We need to find a quadratic example. And we need to find a non-function. That spelling was hard. Let me try that again. Non-function. All right. Okay, so we've got this first table, and honestly, looking at this, like, you wouldn't necessarily know what it is. I'm looking at this, and I'm fairly certain this is going to be quadratic, but let me see if I can convince you. So let me copy down the table first. X, f of x. Let me use my Oakland Public Library card to draw a straight line. One, 2, 3, 4, 5. 5, 12, 21, 32, 45. Okay, so if we want to figure out what something is, the first thing we should do is see if we can find a pattern between the terms, or between the y values. So here, to get from 5 to 12, we know that's plus 7. 12 to 21 is plus 9. 21 to 32 is plus 11. And 32 to 45 is plus 13. Now, if you're not sure on that mental math, that's fine. Go grab a calculator or use the calculator in DeltaMath specifically and check that, right? So if I go to DeltaMath and I do 45 minus 32, I get 13, which is the same thing as, here, let me do it this way. If I do 32, right, 32 plus 13, I get to 45, right? Okay, so what this tells me right here, immediately, the fact that these numbers are different, this tells me that it's definitely not linear, right? If for something to be linear, they all have to be, that addition needs to be the same all the way through. But if you have done the Wednesday activity, you might already notice a pattern here where if we think about how these numbers are changing, right? 7 and 9 are only 2 apart. 9 and 11 are only 2 apart. And 11 and 13 are also only 2 apart. This pattern, the fact that these numbers are a kind of consistent distance apart from each other, this is a good thing. This tells us that the values here are quadratic. Since these are all plus 2, this is quadratic. And just to be specific, it doesn't have to be plus 2. As long as it's plus a number, we're good. So, quadratic. Submit answer. Yes. Green check mark. Feels good. All right, next problem. Okay, so again, I'm looking at this, doing a little bit of mental math, thinking about how we're going to talk about this. And I'm pretty sure this is not a function. Here is how I know that. And if you're following along at home, see if you can figure it out before I say it. Can you figure out why this is not a function? What do you have to pay attention to be able to do that? All right, in this case, the first x value is 1. The second x value is 1, 3, 4, and 5. And then 30, 20, 12, 6, and 2. Okay, did you catch it? Did you see the thing that made this not a function? The thing that made this not a function has nothing to do with differences or finding patterns or anything. This is not a function because of these two entries right here. We have the same x with different outputs. You can think of this as like y if you want. You have the same x when x is 1. Y has to be simultaneously 2 and 6. This is no good. And so when that happens, so same x has multiple y's, we know it's not going to be a function. That's it. But notice, to do this, you have to pay attention to the x's, right? Looking at the y's doesn't help you the same way it did for the quadratics. You have to notice that the 1 shows up twice, but that the numbers across from the 1 are different. You have to notice that to figure out that this is not going to be a function. All right, so not a function. Submit answer. Yes. Green check mark. Feels good. All right, next problem. Okay, this is going to be a parabola. I'm not, or a quadratic. If you don't believe me, do the math. You can figure out the differences and then the second differences. But I'm not going to go through the details on that, just so we can do more. This is, ooh, my mental math is not going well. I think this is a parabola as well. 7, 9, 11, yeah, this is a parabola as well. And just to tell you what I'm doing, I'm counting the differences. So this is +5, +7, +9, and +11. Do you hear the 5, 7, 9, 11 pattern? So I know that that pattern is going to be quadratic. But I would really like to find one that's not a parabola. This is a parabola too. I know it's a parabola because it goes up and then it goes down. Give me something that's not a parabola. Next problem. Thank you. All right. So this one is not a parabola. This one is a function. And this one is going to be a linear function. And let me show you how I know. Now, if you think you know what I'm going to say, great. If you want to see if you can figure out why this is linear on your own or how I'm going to show you, you should pause the video if you're watching the video and see if you can figure this out before I say it. 4, 5, -4, -6, -10, oops, -8. I missed one. -10, -12. Okay, if you paused, welcome back. So to figure out how we know this is linear, we have to think about what is being added or subtracted each time. So to get from -4 to -6, I would need to subtract 2. To get from -6 to -8, I would have to subtract 2. -8 to -10, I'd have to subtract 2. -10 to -12, I would have to subtract 2. What do you notice? They're all the same. So since these are the same, we say that this is constant change. Right? Constant change. And maybe we should be more specific. In this case, it's subtraction. It could be addition. So the constant change is more specifically addition or subtraction change. So constant addition or subtraction each time. And that's what makes it linear. Linear. Yes. Green check mark. Feels good. All right. So now we are hunting for an exponential example. This is going to be linear. And I know that because I'm counting the differences, +2, +2, +2, +2. Okay. So this one is not linear. It is not quadratic. And it is a function. Oh, it's not a function. Look. Oh, I didn't notice that right away. It's not a function. Do you see the 4s? 4 and 4 with 2 different numbers here. This is not a function. Ooh, I almost got tricked. Not a function. Haha, green check marks. That was a bonus problem for you guys who are sticking with it. This is another parabola, or another quadratic, sorry. Man, these exponentials are not showing up. Hey, okay, all right, I think I got one. All right, so this is going to be exponential. And again, if you can, I would say pause the video and see if you can figure out why this is exponential or how you would explain it before I do. 8, 4, 2, 1.5. Okay, so if you pause the video, welcome back. All right, so the pattern here, to get from 8 to 4, you could do addition, and if you did, it wouldn't be the same. Instead, you'd have to notice that to get from 8 to 4, you are dividing by 2, or you can also think of this as multiplying by 1/2, right? Oops, let me scroll this. To go from 4 to 2, you are again dividing by 2, which is the same thing as multiplying by 1/2, and etc., etc. To turn a 2 into a 1, you're dividing by 2, or multiplying by 1/2. And to get from a 1 to a 0.5, you're dividing by 2, or you're multiplying by 1/2. And it's this pattern here that makes it exponential. This is constant division or multiplication change. Right, so linear was linear because it was constant subtraction in this example. This is exponential because it's constant division, or it could be constant multiplication, right? So that's your exponential example. Green check mark, feels good. So those are the 4 examples for the types of problems you're expected to see for this last day of DeltaMath. I hope that was helpful for you, and have a great time working on this. And if I don't see you again, have a great spring break. Bye, everybody. All right, that was my Wednesday tutorial video for DeltaMath. After this stream ends, I'll clip it and then put it up on YouTube for people to watch at their leisure. I'm also thinking I'm probably going to end this stream pretty soon, considering that there hasn't been a lot of input from everyone. I am here to answer any last minute questions, though, if there are any. No? All right, cool. Thanks for tuning in today. I will be on tomorrow, Thursday, but after that, that will be the last day that I'm on until after spring break, because Friday is still Cesar Chavez Day, so I'm going to take it off, and you should take it off as well. And then we have spring break, and then we're going to come back to whatever version of this brand new reality we're in April. So thanks for tuning in, everyone, and I'll see you when I see you. Don't forget to be safe, be sane, and be kind to yourself and to each other. See you later, everybody.